everyone, this is Miss Evangelista, and this is video 4.3, Graphing Rational Functions, and this is the first of two graphing videos that we'll watch for Unit 4. Our objectives for today are to graph rational functions, and we're going to do it by using our asymptotes and intercepts that we know how to find, as well as applying transformations to graphing rational functions. Let's start off by graphing the parent rational function. Hopefully you remember the parent rational function is 1 over x. Start by pausing the video, writing the simplified function, find the asymptotes and intercepts. The simplified function of this parent function is already simplified as 1 over x. You should have found a vertical asymptote of x equals 0, horizontal asymptote of y equals 0, and no x or y intercepts. Let's start by graphing our asymptotes. A vertical asymptote is going to be the vertical line that goes through that x equals 0, goes through our y axis, and we're going to denote that by a dotted line. And I'm just going to move that over a touch, so hopefully you see that that is a dotted line. Now remember, vertical asymptote means that the graph will never ever cross a vertical asymptote. It'll just get really, really close to it, but never cross it. Horizontal asymptote is going to be the horizontal line through the x-axis. There it is. Now remember that horizontal asymptotes, the graph can actually cross through the horizontal asymptotes, but it doesn't always. And we'll look at a couple cases where the graph does cross the horizontal asymptote. Now that I have my asymptotes, I'm going to look at my intercepts. There are no intercepts. If there were, you would go ahead and plot them. How can we graph this rational function? Well, we're going to go back to step 1 when you learned to first graph a linear function in algebra. Let's make a table of values. Now, what we'll find with rational functions is that whatever our vertical asymptote is, it's going to separate our graph into however many sections the graph will have. Now, if we have one vertical asymptote, in this case that goes through the y-axis, what we'll find is that this graph will be split into two sections. The first section will be the area, or the part of the graph that's to the left of the vertical asymptote, and the second part of the graph will be to the right of the vertical asymptote. Okay, so we'll have two graphs, and I need to figure out points. I need to make a table of values for the left side and for the right side of the graph, and we're going to plot those. Well, let's pick nice values that can determine the behavior of the graph on the left side. On the left side, how about let's pick x equals -1. When x equals -1, y equals -1, let's plot it. -1, and I'm going to move this so that I can see my coordinates. -1 to -1 is this value right here. And we need to pick at least one more point. Let's try -2. If I plug in -2 into the original function, it's -1/2. -1/2. -1/2. Okay, that's that point right there. Once you have plotted 2 points on each section of the graph, you're going to use the behavior of the asymptotes to fill in the rest of the graph. If we connect these 2 points that we already found, and we're going to look to the left of this graph, the left of this graph, its end behavior is going to get really close to that horizontal asymptote, but it's never going to cross it. Okay, and let's just test a value. What would happen if we plugged in -100 into our original function? Well, we would get -100. So hopefully you can see that we would get really, really close to that horizontal asymptote, but in this case it would never cross it. If we look, and I know that's a really messy messy sketch, sorry. Hopefully you get the idea. But between 0 and -1, if we were to pick a point between here, we would see that the y values would get more and more negative, and it would look like this. Okay, now let's do the same thing for the right side of our graph. This time, let's plug in a value to the right of our vertical asymptote. X equals, let's plug in 1. If I plug in 1 into our original function, that gives me y equals 1. Got it. Next point, 2, x equals 2, y equals 1/2. Okay, and again, if we're looking, just connect the 2 points that we have, and then since we have a horizontal asymptote here, the graph is going to get really close to that horizontal asymptote, and then to the left to complete this part, the graph is going to get really close to that vertical asymptote this time. And once we have a complete graph for each section of the vertical asymptote, we are done. And just to show you what the graph looks like on the calculator, so you can have a smoother curve. Okay, this is a graph of 1 over x. Make sure that you know how to type this into your calculator. So what we see is that there are 2 branches of the graph that are split between the vertical asymptote. Now, the domain of this graph, make sure you know how to find it, all of the x values. We can have any x value except for the x equals 0, except for x equals 0. And if we're looking at domain, which asymptote would we look at? Our vertical asymptote or horizontal? Our vertical asymptote. X equals 0, remember, that means the graph will never cross x equals 0. Horizontal asymptote is also the same, all reals except for 0. And for the range, you can look at the horizontal asymptote to help determine that. Okay, let's look at one more example. And the next example, we are going to apply transformations to rational functions. So make sure you copy this form right here. Y equals a over x minus h, all of that plus k. Okay, so what we learned before about transformations of other parent functions, we're going to apply them to rational functions. What we'll find is the h and the k, if you recall, dealt with the horizontal and vertical translations of the graph. So the h is still going to be the horizontal translation. If we have x minus h, that'll move the graph up to the right h units. If we have x plus h, the graph will move to the left h units. The k, if you recall, deals with the vertical translation. It will move the graph up or down k units. And go ahead and copy this too, but we're about to see why this is true. The vertical asymptote will be x equals whatever our h value is. Our horizontal asymptote will be y equals k. Our second example, we're going to use transformations to graph this function, y equals negative 6 over x plus 2 minus 4. The first thing you need to recognize is that this is a rational function. Okay, now let's look at our transformations here. Just based on the previous graph, or the previous slide, sorry. If we look at the denominator, this is my x minus h, but in this case I have x plus 2, which corresponds to an x plus h, okay? This means that if it's in the form x plus h, the graph is going to move left 2. And we're comparing the parent rational function, okay? So if you recall from the previous example, the first example we did, the parent rational function looks, trying to be as smooth as possible. I'm doing this on my mouse, so it's not as easy as it looks. Yeah. Sir. So in blue is y equals 1 over x. We're going to apply the transformations to shift this graph and graph it appropriately. If the graph is shifted to the left 2, if this is going to move our vertical asymptote. Our vertical asymptote was previously the y-axis, but now for this example, the graph is going to move left 2, which moves our vertical asymptote to negative 2. So go ahead and graph the vertical asymptote with the negative, or with the dotted line. And I'll graph our actual function in pink. Okay. So I know there's a vertical asymptote. Now I need to figure out where there is going to be a horizontal asymptote. To find the horizontal asymptote, I'm going to look at the k. K equals negative 4. K equals negative 4 means the graph is going to move down 4. So let's think about this. If I'm using the parent rational function to graph this, before my horizontal asymptote was the x-axis, y equals 0. It's going to, my horizontal asymptote will move down 4, making my horizontal asymptote now negative 4. Plot that with a dotted line. Let's label it. This is negative 4 right there. Okay. And now, remember that the vertical asymptote separates the graph into two sections. To the left of the vertical asymptote, so to the left of negative 2, we're going to look at what the graph looks like. And then, what does the graph look like to the right of negative 2? Now I'm going to erase the graph of the original function because it's going to get in our way. Let's go ahead and make our x and y table now. We can make our x and y table down here to figure out what the graph is going to look like to the left of the vertical asymptote and to the right. So to the left of the vertical asymptote, what x value should we pick? Anything to the left of negative 2. Negative 3, how about it? Negative 3. If x equals negative 3, plug that back into the original function. That gives us 6 over negative 1, which cancels out here. 6 over negative, that's 6 minus 4, which gives us 2. Negative 3 and 2, oops, negative 3. 2's right there. Let's test another value. How about negative 4? And we see if you plug negative 4 in, you get a y value of negative 1. Oops. Negative 1. Okay. And now we're going to use the behavior of our horizontal asymptotes to complete this branch of the rational function. Connecting the two dots, this function appears like it's decreasing when we're looking at it as it's going to the left. So it's going to get really close to that horizontal asymptote at negative 4. And the graph, as it gets closer to the vertical asymptote, will get closer and closer as it goes up. Now I need to figure out an x and y value for the right side of negative 2. How about negative 1 and 0? Go ahead and pause the video and find those y values that correspond. Negative 1 gives us a y value of negative 10. Negative 1, negative 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if we plug in 0, we get negative 7, 0, 9, 8. Okay, use the behavior of the asymptotes to fill in the rest of the graph. Let me just extend our vertical asymptote so we can see what it's doing. The graph's going to get really close to our vertical asymptote. I'm going to show you the calculator version in just a minute. And then the graph will get really close to our horizontal asymptote. And this is our real graph. Let me show you what it looks like. Okay, so our nice pretty version is right here. And we see that we have a vertical asymptote at negative 2, horizontal asymptote at negative 4. Make sure you know how to type this into your calculator to check your answer. Be very careful with your parentheses. Let's check the rest of our answers. We know that we can find the x and y intercepts. There's the work for it so that you can check your